Now that we've taken a look at the get attribute protocol, and we've taken a look at details like the method resolution order, we might think that we're ready to take a look at the actual underlying mechanics of the get attribute protocol and write our own version of get attribute, re-implement this in Python so that we can ensure that we have a thorough understanding of how everything works. However, there is one detail missing, one critical detail that comes up more often than you'd think, that has kind of a funny name, that seems a little bit obscure, but when you look closely at what it really is, ends up being a very mechanical thing indeed. It is the descriptor protocol. Let's take a look. Here, we have three classes that form a hierarchy. B inherits from A, C inherits from B, and at each level we have some piece of data, X, Y, Z, and W. And we can think that what we know about the MRO and what we know about the get attribute protocol, we should be able to implement everything so that in our own custom get attribute method, we can basically mimic exactly what happens in the actual get attribute method. Get attribute says when you look up X, you get 1. In our own get attribute method, we should be able to do the same thing. So let's give it a try. Well, here, X is coming from A, and we know that it's not found in the underlying instance. It's being found in the basemost class, and so we have to implement a couple of different mechanisms. One of the things that we might say is, you know what, the very first place we're going to look for an attribute is we're going to look for it in the instance state, and assuming that we don't care about slots here, and between you and me, we care about slots much less than a lot of people seem to think we care about slots. What we'll do is we'll just look in the object's instance state, which will be visible as this dictionary object. And so we'll say if the attribute is there, just return what you see there. And while that won't solve this particular problem, it will give us the ability to mock out what happens when we look for this W entity. That's all that's necessary in order to make that work. Now, to make X, Y, and Z work, to make looking for this particular piece of data up that class hierarchy work, we have to say, you know what, if we didn't find this in the object's instance state, we need to look in the class's state, and we need to look in the class's state starting from our type up the hierarchy. And so the next thing we could say is we could say if the attribute is in my types dictionary, then basically repeat that same idea, and there you go. And that doesn't make X work, but it makes Z work because Z was some data that was stored in this object. So you can see we have a little bit more of this working. In order to make X and Y work, we need to look up the type hierarchy, we need to look up the MRO. And so we can make both of these work by just slightly amending this line here. Instead of looking just in the type of this object, we can look down the MRO. So we could say for each class in the MRO, if that attribute exists in that class's data, in that class's state, assuming that we don't care about things like slots, here we can see a full implementation where X, Y, Z, and W work. And you can see this is basically the get attribute protocol as it applies to instance state and state that you might find up the MRO. But I have added one more thing to this example. I've created an object here called D, and I've assigned it to an attribute called ABC. And if you take a look at what happens when you look up this ABC attribute, you get something kind of interesting. You didn't get that D object back out. You got a number. How did that work? Does that ever happen? Well, in fact, that happens quite a bit in practice because think about it. If you look up a class method or a static method or a property, you don't get that class method, static method, or property object back out. What do you get? Well, you get the invocation of that property, or you get a method that is bound to that class, or in the case of an instance method that's bound to that instance, inserting that implicit self argument. And in the case of a static method, well, maybe that's the actual only case where you get the actual method back out. Well, how does that work? Well, one thing you can see is that we have chosen to call this class D because it is D for descriptor. This is the descriptor protocol. The descriptor protocol is merely a very slight amendment to the get attribute mechanism. if you can see here on the screen, the getAttribute mechanism, first look in the instance state. If you don't find it, then look in the class state. Look in the class state up the MRO. Well, there's one more step. What you'll do, if you find something strictly in the type or any of the base types, is you will check, does that thing that I just found have a special method? And if it has that special method, what you're going to do is you're going to return the invocation of that special method. And you're going to pass it a couple of arguments. One of the arguments you're going to pass is the instance in which you found it, and the other ones you're going to pass is the owner. And here you can see an example of me putting two arguments in here. For the purposes of this example, I don't really care what the instance of the owner are. And if it doesn't happen to have those methods, then you just return whatever you found. Now, if you take a look at my implementation of getAttribute, it seems to work. And if we zoom in on my implementation of this object, this descriptor, we can see it has this get method that takes those three arguments. This is how class method works. This is how instance methods work. This is how property works. It's not exactly how static method has to work, but we can create our own static method that makes use of this descriptor protocol in order to return the underlying object. But you can think the static method is really the absence of the descriptor protocol being implied. And so you could implement it in that fashion. And this is the one major missing piece to our understanding of the getAttribute protocol. There are, in fact, two more critical pieces for us to get as close as we possibly can get to an implementation of our own Python-based getAttribute. As I said, there are some cases where we will not be able to mock this up in pure Python. Then if there are slots require that you look up the attribute in some storage that is not directly visible from the Python layer. And as a consequence, you'll need some tricks to dive deeper into the actual slots, the actual array of this instance state. And that might not be easy to do from pure Python, but ignoring mechanisms like slot, you can see for the majority of the mechanisms that we care about when it comes to getAttribute, you can see them employed here with the exception of two other mechanisms. For example, if the object's type happens to have a getAttr or getAttribute method implemented. And so, to conclude our mostly working implementation of getAttribute, you can think that the two steps that we'd have to add here are, we'd have to check if there is a getAttr, and we'd have to check if there is a getAttribute. And you can see the distinction between these two methods just comes down to, do you look first or do you look last? And so the final missing piece here is we need to check if the object happens to have one of these special methods, getAttr or getAttribute implemented, that intercept this protocol. And as part of our implementation here, all we have to do to get this as close as we possibly can get this in pure Python without any special tricks is to check if getAttribute is implemented or getAttr is implemented. And you can think that for these two protocol methods, getAttribute with 2 underscores before and after, getAttr with 2 underscores before and after, the distinction is quite slight, but is visible here. Do you unconditionally invoke this protocol before you look anywhere else? Or do you only invoke this protocol after you have exhausted all the other places you could look and you couldn't find it anywhere else? Here you can see a mostly working reimplementation of this getAttribute, getAttr protocol in Python. Is actually a fairly mechanical process. And this descriptor protocol, despite the intimidating and somewhat confusing name, why is it a descriptor? What does it describe? Setting all of that aside, it's actually fairly straightforward. It's just one little step, one little mechanical step in our process of figuring out if I ask for an attribute, I perform this lookup with some bounded input, where do I find it and what do I do when I find it? And you can see it's just a bunch of steps. Unconditionally call getAttribute, look in the instance state, look up the class hierarchy. If you happen to see something in the class hierarchy and it looks a particular way, do something special. And if it's not there, you attribute error, the attribute wasn't found. So here you can see an implementation of our getAttr protocol and an understanding for how the descriptor protocol fits into it. In the next video, we're going to take a look at what we can do With this descriptor protocol, we're going to re-implement from scratch class method, static method, instance methods, and property. Stay tuned. I think you'll really enjoy it.